video that we did, we solved this shear and moment diagrams for a uniform load and a point load, and then we put them together, and we came up with the results shown here. And now I want to show what happens if you accidentally or incorrectly solve the shear and moment diagrams using the resultants. So take a look at this. We're going to start with this one, and this is what it looks like for the real loading. And I'm going to go ahead and solve this one below using the resultant. And of course, the resultant would be that 2 kip per foot load that you see there. That would be that's uniformly distributed. We'd place that right in the middle as 60 kips. So we'll do that in a second, and we'll show how that looks totally different from what we're seeing here. Okay, so let's go ahead and do that. So again, what we see here is the resultants, and I've written down the reactions over on the right here. And the reactions, of course, are the same as with the uniform load because that's how we got the reactions. And I want to point out that the shear and moment diagrams that I'm about to draw are correct for the loading that we see, but I want to show that the answer we get is different than the answer we got for the uniform load. And so again, we're going to start with 90 kips over here. We go up 90 to 90 kips. But this time, instead of dropping down to 70 kips, because there is no load between this point and here, the change in shear is 0. So we stay at 90, and then we drop down 90. So if we're going to drop down 90, we get down to 0. And because, again, no change, no load applied here, no change in shear, therefore no change. And then we drop down 60 and straight across. So this takes us to minus 60. And then back up to 60 kips. So that's the shear diagram here. Again, the shear is 0 across the middle here. And our change in moment between point A and the first load is equal to this area. So A is equal to 90 kips times 10 feet. And that's equal to 900 kip feet. So from here to here, we're going to go up 900. If I can draw it correctly here. We go up to 900 kip feet. Because the area here is 0, the change in shear, change in moment is 0, so we stay at 900. And the area here is 15 feet times 60 kips. And it's a minus 60 kips, so it's a minus 900 kip feet. So then we drop back down to 0. So you can see the difference with this one is that we have straight shear and moment is straight lines, and the maximum moment happens across this entire region in the middle, and that maximum moment is higher than the maximum moment we got here, which was 800 kip feet. So although if this was your actual loading, if you actually had a 600 kip point load in the middle and actually had a 90 kip point load, this shear and moment diagram would be correct. However, if the problem you're solving is a 90 kip load with a 2 kip per foot distributed load, then your proper answer would be shear and moment diagrams that look like this.